Okay, good morning, everyone. Good morning, Desire. Joy, good morning. Precious Mary, good morning. You are welcome. Grace Godwin, good morning. You are all welcome. So our topic today is going to be touching a lot of things. And do me well to like, share this video. Keep on liking this video as we're about to start. It's already 7. All right, so when we talk about alternating current, we are going to touch a lot of things. Start and finish it. Every question necessary for alternative current, we shall deal with it. Okay? Shall deal with it. So, you are all welcome to my live video. Okay, so we are going to talk about alternating current. AC current. AC current. So the full meaning of AC is alternating current. Is alternating current. Okay? So alternating current alternating current is the current that reverses its direction after certain time interval. All right, so when we talk about alternating current, is the type of current that reverses its direction after certain time interval. Okay, it is actually periodical. It changes periodically. It changes periodically. For example, an alternating current has up, down, up, down, up. Okay, that is how the thing moves. And here is positive, negative, positive, negative, positive, and so on and so forth. It alternates. Positive, negative, positive, negative. Okay. Now, this alternating current can be represented in a graphical way. You can represent it in a graphical way. Okay. And the graphical representation of it is very simple. You can represent it in waveform. Waveform. Periodic function is sine wave that is symmetrical about the origin. Periodic function, sine wave. This is the origin. Okay. And from here is the amplitude. Considering this to be voltage waveform or current waveform, here is peak current or peak voltage. Okay, that is the amplitude, either peak current or peak voltage. Now, from here, this is 0. Sine 0 is 0. Okay, this thing now is formed using sine function. Okay, using sine function. So, either you see it as Im or I see it as Vm. Okay, now what you can see right now is sinusoidal waveform. Let us imagine that you are having it as V. V, which is equal to Vm, peak voltage, sine Wt. Okay, so this is the root mean square or instantaneous voltage. Voltage at every instant. Okay, then if here is 0, here is pi, here is 2 pi. 0 to pi is half cycle. 0 to 2 pi is full cycle. Remember, the period of sine function is 2 pi. You remember? The period of sine function is 2 pi. That means from here to here makes 1 period. And period is the time taken for a particle to complete one oscillation. So from here to here is 2 pi. That is the period of a wave uh, of alternating current or sine wave. Okay. So because of that, it start repeating itself again. You understand? This is called periodic function. Alternating current is a periodic change. It changes periodically. So half of this is pi all over 2. Yeah, pi over 2. Why here is 3 pi all over 2. Yes, here is 1 pi over 2. Here is 2 pi over 2, which is pi over 1, which is pi. Here is 3 pi over 2. Here is 4 pi over 2, which is 2 pi. Here is 5 pi over 2. Then here is 6 pi over 2, and so on and so forth. So this side is time. See? Okay. So this is called the waveform, voltage waveform, voltage waveform or current waveform. Vm is the maximum. Vm is the maximum voltage or peak voltage, while Im is the maximum current or peak current. Onyibechi Nonso, good morning. You are welcome. Joy, good morning. Victoria, you are welcome. Good morning. All right. All right. So, as I said, V is equal to V naught sine Wt, where W is equal to 2 pi F. Okay? So you have V is equal to, either I use V naught or Vm, no problem. 2 pi Ft. That is the voltage waveform. Voltage waveform. Similarly, current I is equal to I naught sine Wt. Okay? Then I is equal to I naught sine 2 pi Ft. Okay? Where F is the frequency, 2 pi. 2 pi is the angle, F is the frequency, then T is the time. Okay? And we call this instantaneous current or instantaneous voltage. Voltage at every instant or current at every instant. Okay? So that is it. Now, there is what we call the root mean square. The root mean square. Okay? When we talk about the root mean square, we have root mean square voltage or root mean square current. Root mean square. I hope you can hear me clearly. I hope you can hear me clearly. I hope you are following. Okay. I hope you are following. All right. So when we talk about the effective value of an alternating current, we are actually talking about root mean square. It's also called the root mean square value. So when we talk about the effective value of an alternating current, you're still talking about the root mean square value. The root mean square value. Okay. So you have known that the effective value is the same as the root mean square value. Now, what does it mean? It means that the root mean square value, the root mean square value is defined as the is defined as the value of direct current is defined as the value of direct current which should dissipate heat at the same rate in a given resistor. In a given resistor. So we have the root mean square voltage and root mean square current. So RMS current is equal to peak current all over square root of 2. Similarly, RMS voltage is equal to peak voltage all over square root of 2. Okay, peak voltage all over square root of 2. All right, so that is how we do it. Now, let's see that given I equal to 80 sine 200 pi t. Okay, 200 pi t. Find the root mean square current. Okay, very simple. When you're given a question like this, you compare. We already know dot I naught is equal to 80 ampere. So I RMS is equal to I naught over root 2, 80 all over root 2. So because it's 80 over root 2, IRMS is equal to, if you punch your calculator, you have 56.6 ampere. And punch your calculator to get your final answer. 56.6 ampere. Okay, so when we talk about heat is equal to I squared RT. I squared RT. So in case a question is given like this, calculate the amount of heat generated in an external circuit. In an external load of resistance 8 ohm if an AC of peak value 5 ampere is passed through it for 100 seconds. So when you are given a question like this, you don't need to think too much. You have the formula for heat. Formula for heat is I squared RT. So I can leave you to solve the question and let's see how you can get the final solution to that. And let me know how you can think of the actual solution to use. Take note, this current here is not IRMS. Okay? While solving for this question, don't ever use this current that you are seeing here as IRMS. This current is called instantaneous current, or you can call it current but this current is not IR, it is an instantaneous current. So if you are given peak current, okay, you can easily find I instantaneous current. So this is peak current, this is instantaneous current. So they are not the same. Take note to this current is not peak current. So you dare not use this 5 here and so you will fail it woefully. Okay, if you use this 5, if you apply this 5 ohm now, because this 5 ohm is called peak value. So if they give you peak value in a question, remember to convert it to instantaneous current. Okay, it's very, very important. You convert it instantly to instantaneous current. I hope you are following. I hope you are following. I hope you are following. Okay. All right. So let's solve the question. Let's take out the parameters. Okay. R was given as 8 ohms. Peak current was given as 5 ampere. Time 100 seconds. So how do we solve it? We are looking for the heat generated. Heat generated is equal to what? I squared. You look for current, instantaneous current. Instantaneous current is equal to I naught all over root 2. Please take note, this instantaneous current is the same thing as root mean square. Is the same thing as root mean square. So I naught over root 2. And we already know that I naught is 5 over root 2. Okay, so we've already known the instantaneous current now. We are now going to apply it in our formula I squared RT. So 5 over root 2 all squared times R was given as 8 times T 100. Okay, 100. So that 5 squared is 25. Root 2 all squared is 2 times 8 times 100. Now, this is 2. Cancelling this, we have 400. So we say 25 times 100. We have 2,500 multiply by 4. So this is 0, this is 0, this is 0, carry 2. 4 times 2 is 8, plus 1. Okay, so this is 10,000. So the heat is 10,000 joule or 10 kilojoules. 10,000 joules or 10 kilojoules. Okay, 10,000 joules or 10 kilojoules. Okay. What we have is resistive circuit. A circuit that contains only resistor is called a resistive circuit. A circuit that contains only resistor is called a resistive circuit. Okay? It's called a resistive circuit. Circuits that contains only resistor is called a resistive circuit. Now, when we talk about a resistive circuit, we are actually talking about this. This is circuit that has only resistor. And if you have a source like this, you know that it's alternating current, AC source, which could be V is equal to Vm sine Wt, alternating voltage source. And this is resistor. Okay? This is resistor. You connect it to this point. This is a pure resistive circuit. Purely resistive circuit. Okay? It's a pure resistive circuit. I hope it's clear. It's a pure resistive circuit. And the current that flows crosses through it and produces voltage as IR. Okay? Produces voltage as IR. So we can understand that the current in the resistor is in phase with the voltage across the resistor, across the two terminals. The current in the resistor is in phase across the is in phase with the voltage across the terminal. See what it means. The circuit that has only resistor is called a resistive circuit. Now, when we say it's in phase, let's say this is the voltage, then current will still pass through the same point. Have you seen this? So if this is the current, this is voltage. They are in phase in the sense that they pass through zero at the same time, through pi at the same time, they reach here at the same time, they form complete circle at the same time. Okay? They form complete circle at the same time, and they are in phase. See it here. So this is R, and this is if we're considering this as current, this is current and voltage are in phase with the resistor. They are parallel. So there is no phase angle. Phase angle difference is equal to zero. Phase angle difference is equal to zero. There is no phase angle difference. So they get to zero at the same time, maximum, minimum, and so on and so forth. They are just in phase. They move in phase. If this one reach maximum, this one reach maximum, So reach 0, continue like that. At the maximum of this is not more. The zero of this, they reach both maximum, zero, and minimum at the same time. When I say they are in phase, it means that they reach zero. They passes through zero, reach maximum at the same time, reach minimum at the same time. Okay? So that is how the thing goes. Now let's see. I hope you understood this graph. This graph shows that they are in phase. This is phasor diagram. So this is the waveform. Okay? The current and voltage waveform. You understand? When you see this type of error, you call this a resistive circuit. Resistive circuit. Now, the next one is a capacitive circuit, a circuit that has only capacitor. A circuit that has only capacitor is called capacitive circuit. A capacitor so a capacitor, we all know a capacitor is a device. Okay? A capacitor is a device capacitor is a device that stores charges. It's a device that stores electronic charges. Okay? So a pure capacitive circuit does not have resistance or inductance. A pure capacitive circuit doesn't have resistance or inductance. I hope you are following. I hope you are following. Okay? I need you to follow this. Very important. Kindly like and share. Like, click on the like button. Like this video. Okay? Like this video. Like it and share it. Keep on liking it. All right, so when we talk about capacitive circuit, we're actually referring to a circuit that has only capacitor without resistor or inductor. Therefore, no resistance and no what? Inductance. So that is when we talk about a circuit that has only capacitor, capacitive circuit. All right. Whenever an alternating current is applied to a capacitive circuit, the capacitor, it charges first in one direction and then in other directions. So it has charging in two directions. Current leads voltage by 90 degrees. Okay. Current leads voltage by 90 degrees. So for a capacitive circuit, when we connect a capacitor to a voltage source, AC circuits, when you see something like this, AC circuit, and this is a capacitor, okay? So it charges in one direction and then in another direction. So it doesn't charge in only one direction, it charges in both directions, one direction, another direction, because it is also called what we call alternating current. All right. Now, good morning, Igwe Nancy, you're welcome. Good morning, Anastasia Obaji, you're welcome. Okay. And I hope you are following. Kindly like and share the video. Kindly like and share the video. Okay. Like and share the video. Keep on liking. Kindly like and share the video. All right. So remember, the voltage source of an AC circuit is instantaneous voltage or root mean square voltage. Okay. So which is V M sine omega t. Now, this is capacitance. We can call it capacitor. Now let's look at the waveform. Let's look at the waveform of capacitor. Current leads, okay, voltage by 90 degrees. Current leads voltage by 90 degrees. So when current starts from zero, voltage gets to zero after 90 degrees when t is zero. So now, let us say that we're having a time here, current and voltage. And this is zero. Current moves this way, and voltage moves this way. Okay? We want to get it clearly. Current, I is current, which is leading by. This is current, then this is voltage, and voltage is lagging by 90 degrees. So this is voltage, okay? There is maximum point. I can say this is 1 cosine 1. Now, this point here is 0, here is 19, or pi over 2, okay? This is 0. So current is leading this, because if you bring this down, you see that this is minus pi over 2. So current have already started from 0 before this one start from 90 degree, but is lagging behind. Okay, so that is why you see that here is plus 19. You have already added 90 to voltage before current even starts. So that means we've already had, if you check it here, there was 90 plus 90. Okay, we've already added 90 to voltage before correct. So we see make minus pi over 2 to 0. That is the phase angle difference is 0 minus 0, and pi over 2 is plus 90. That's why I have same plus here. So now this is phase angle difference. Now you now see that this one is already 0. Okay, and this one started minus 90 later ago. Why this one started from 0? So current leads voltage. Current leads voltage. This is very important. Current leads voltage by either pi over 2 radian or 90 degree. So that is the main point, okay? Keep on sharing. Keep on sharing. Keep on liking. Share the video. Okay. Keep liking the video. Keep liking the video. Okay, so the phase difference, like the video, like in the video. So the phase difference of a capacitor in an alternating current circuit offers a resistance or reactance. The phase difference of a capacitor in an AC circuit offers a reactance offers a reactance called offers a reactance called capacity reactance. Called capacitive reactance. The phase difference of a capacitor in an AC circuit offers a reactance called capacitive reactance. See it here, SC. Capacitive reactance, SC. And this capacitive reactance acts like an like a resistor. Okay, it is measured in ohms. It is measured in ohms. So it acts like a resistor opposition. So what do we mean by a reactance? A reactance is the overall opposition offered by either capacitor or inductor in electrical circuit of an alternating current. Okay, I'll take it again. A reactance is the overall opposition offered by either capacitor or inductor in electrical circuit of an alternating current. So capacitive reactance is an opposition offered by a capacitor. That means this is opposition ohms, resistor. Okay, we already know that resistor is an opposition itself to the flow of current. So we need to know the opposition offered by capacitor. It is called the capacitive reactance. Then the opposition offered by inductor is called inductive reactance. So the general formula for capacitive reactance is XC is equal to 1 all over WC, which is equal to 1 all over 2 pi FC. So this is capacitive reactance. It's capacitive reactance. So you need to take note of it. It's very, very important. XC is equal to 1 all over WC, which is equal to 1 all over pi FC. So this is capacitive reactance. Capacitive reactance. So you need to take very, very An alternating potential difference of 24 volts is connected across 120 microfarad capacitor with a frequency of 60 Hz. Calculate 1. The reactance of the capacitor. 2. Current in the circuit. All right, so you can try this. Check the parameter given. They gave you voltage, 24 voltage, 24 volts. They gave you capacitor C, 120 microfarad. They gave you 60 Hz frequency. We already know that the formula for capacitive reactance is XC. Okay? All right, so you can try this. XC is equal to 1 over WC, and W is equal to 2 pi F. Okay, so XC is equal to 1 over 2 times W is 2 pi 3.142. This is 2 pi times frequency is 60. Then C, which is capacitor, is 120 times 10 raised to the power. Micro means minus 6. So punch everything in calculator. Tell me what you have as SC and verify whether your SC is equal to 22 ohms. So this is I. Yes, Desire, you are very correct. 22 ohms. Okay, and the current is 1.08 ampere. Desire, you are very correct. You got it. Okay, that is sharp, sharp. Now the formula. So the formula to use for the current is equal to V is equal to I SC. We've already know what SC is now, 22. We are looking for current. So we make current the sub-data formula V all over SC. So what is V? V is 24, which was given in the question. 24 all over 22. So it implies our current is equal to 1.09 approximately. So our current is 1.09 ampere. All right, a 10 microfarad capacitor is connected to a 220-volt AC supply with a frequency of 60 Hz. Calculate 1. The root mean square value of the current in the circuit. 2. The maximum potential difference across the capacitor. So who have gotten the answer? You're supposed to have known the answer by now. Who have gotten the answer? You're supposed to have known the answer by now. All right, the parameters are C is equal to 10 microfarad, then V is equal to 220 volt, F is equal to 60 Hz. Now, root mean square value of the current. When we talk about the root mean square value of the current, we'll first of all calculate the capacitive reactance, which is 1 over WC, because V is equal to I XC. I is equal to V all over XC. So how do we get our XC? X is equal to 1 all over 2. Here W is equal to 2 pi F. 2 times 3.142 times 16 times 10 times 10 raised to the power minus 6. Okay. So if you point your calculator, your XC will give us 265.26 ohms. So we'll now say I is equal to V over XC, which is 220 over 265.26, which will give us 0.83 ampere. Okay, but the question says the root mean square value of the current, okay, which is 0.83, correct. Now, number 2 says the maximum potential difference. We already know that V maximum or V peak is equal to I is equal to V all right. So I is equal to 0.83, Vm is equal to 311.13. You are asked to find just the root mean square current, not peak current, which is 0. Okay, let's talk about inductive circuit, purely inductive circuit. An AC circuit that contains only inductor is said to be an inductive circuit. So this is the circuit that has only inductor and is connected to AC source, where V is equal to V M sine WT. So in this circuit, the voltage leads the current. The voltage leads current by I all over 2 for 90 degrees. So inductor also has a resistance too. We call it inductive reactance. Inductive reactance. Inductive reactance XL is equal to WL, which is this 2 pi FL. The unit of inductance is Henry. So let's pick a question on that and let's know what to do about it. A 220 volt 50 hertz is connected across an inductor of inductance 10 Henry. Calculate the current that flows through the circuit. So here, we've already known voltage, and this voltage given is called the root mean square voltage or instantaneous voltage, 50 Hertz. Then Henry is L, which is 10 Henry. Calculate the current flows. So current is equal to, anyway, we have that voltage is equal to I X L. Okay, this is VL. So current therefore is equal to VL over XL, which implies that current is equal to VL is what? 220 2 times 3.142 times 50 times Henry 10. Okay. So if you multiply and divide, current will be 0.070 ampere. Keep on sharing. Keep on sharing. And if you know you are hearing me, like and say that I can hear you. If you can hear me clearly, say that I can hear you clearly. Keep on sharing. Like the video. Like the video. And keep on sharing. Desire, I can see you. Only Beijing also, I can see you. Keep on liking the video. Igwe Nancy, can see you. All right, so let's keep it going. Keep on liking, share the video. Share the video. Let's consider RL circuit. All right, so keep on liking, keep on liking. Right. So what do we mean by RL circuit? A circuit that contains what do we mean by RL? Resistor. Okay. And resist inductor. Okay. So when this occurs, we do not consider only resistance again. We now consider resistance again. Because resistor, we have opposition offered by resistor, opposition offered by inductor. So now we need to know the overall opposition that is offered by the circuit. So now we need to know the overall opposition that is offered by the circuit. So in doing this, we have to understand that current that flow through them is the same. So the same current flows through if they are in series. So the overall opposition of current flow is called impedance. I hope you are hearing me. Can you hear me? Is it clear? Are you following? Keep on sharing and like the video. Okay. The overall opposition, okay, of current to the circuit by the circuit is called impedance. So impedance, therefore, is R plus XL. Okay. As you can see, this is impedance. It is expressed in vector form. So we now have the magnitude is square root of R squared plus XL squared. All right, I hope it's clear. Because from here we can say phi is equal to XL all over R. Phi is equal to tan inverse XL over R. So this is all about RLC circuits, RL circuits in series. This is all about RL series. So if you want to calculate the current, okay, that passes through this total current, we have V is equal to IZ. So I is equal to V all over Z. I hope you can hear me clearly. Keep on sharing, keep on liking, keep on liking. We are progressing. We are progressing gradually. We are progressing. Progressing. All right, so let's look into RC circuit. We've talked about RL circuit. Let's say RC circuit. Connection between R so here is R. Right, so let's and here is C. So in this case, we have R and we have C. Then we have XC. We have impedance. Okay. So impedance here is the overall position that is offered by the circuit, which is R plus JXC. All right. So that Z magnitude will give us square root of R squared plus xc squared. Remember that xc is equal to 1 all over 2 pi fc. And this is connected, RC circuit connected in series. So phi is equal to tan inverse of xc all over r. Let us say that you are just asked to find the phase angle difference. That is the formula I use. Okay, J stands for imaginary. J stands for imaginary. Complex, square root of minus 1. So I hope you can hear me clearly. All right. We have what we call RLC circuit. In series. So in this case, Z is equal to R plus J XL minus XC. Okay? So Z magnitude is equal to square root of R squared plus XL minus XC or squared. So we can call xl minus xcx, so that we have square root of r squared plus x squared. So v is equal to iz, okay? Then we can calculate the current as v all over z. Also, we can get the phi as what? Tan inverse of xl minus xc all over r. All right, so that is that for RLC circuit. Under RLC circuit, something normally happens. We call it resonance. So I'm going to give you condition at resonance. What do we mean by resonance? Resonance is when xc is equal to xl, or xl is equal to xc. At resonance, maximum current occur. So at resonance, we have maximum current. Okay, at resonance, impedance is equal to resistance. Okay, so at resonance, a lot of things happen. So resonance in the RLC circuit is achieved when the current is maximum. So this also happens when XL is equal to XC. At this point, the effect of capacitor and inductor are neutralized. So at resonance, XC is equal to XL, or XL is equal to XC. Okay? So we are going to learn what we mean by resonance frequency. But for the meantime, conditions for resonance: impedance is minimum, it is reduced to R. Yes, the theta you are seeing there is phase difference, yes. PF is 1. Power factor is 1. So this is condition for RLC resonance, or resonance in an RLC circuit. Igwe Nancy, you're correct. That theta is phase angle difference. Okay, to find it in an RLC circuit, we use tan inverse of XL minus XC all over R. So these are the conditions for resonance in RLC series circuits. I hope you are following. I hope you are following. Keep on liking, like the video, share the video. Like the video, share the video. Okay, keep on liking the video and share the video. Keep on sharing the video. So let's fire down. So we are going to massively solve questions. Okay? We're going to solve questions, marathon question now. Are you ready? Keep on sharing the video. Keep on sharing the video. Are you ready? Say, I am ready. If you are ready, say, I am ready. If you are ready. If you are ready, you say, I'm ready. Good. You're going to say you're ready. Let's go. So when they ask you, what is an AC circuit? What will you answer? What is an AC circuit? Okay. An AC circuit is an alternating current that changes periodically. AC circuit, AC circuit, or let's say AC current. Okay. AC current is an alternating current that changes direction periodically. It changes direction periodically. Alternating current that changes direction periodically. So that is AC circuit. If they ask you, what is an AC circuit? Periodically. Okay. AC current, alternating current that changes direction periodically. All right. So now, frequency. What is frequency? Frequency of AC current. Frequency of AC current. Frequency of AC current frequency of AC current What is it? An alternating current that changes direction periodically. Changes direction periodically. Alternating current that changes direction periodically. That is, it is a, that's what is an periodically. Okay? AC current, alternating current that changes direction periodically. All right. So now, frequency. What is frequency? Frequency of AC current. Frequency of AC current. For one cycle, we have period, one period. So the time taken to complete one cycle is the period. Period is the time taken to complete one cycle. Okay? So the relationship between period and frequency is on the board. Relationship between period and frequency is on the board. Now, the SI unit of angular frequency, SI unit of angular frequency is radian per second. Radian per second or rad per second. Okay, that is the SI unit. The SI unit of frequency is hertz. Hertz. Now, the SI unit of angular frequency, SI unit of angular frequency is radian per second. I hope you are following. No? If you are following, you say, I am following. Type, I am following to show that you are following. I am following. Type, I am following. Type, I am following to show that you are following. Type, I am following. Still on AC circuit. Type, I am following. I hope you are following. If you are following, you say, I am following. I am following. Show that you are following. I am following. I am following. All right, good. I am following. Victoria, you are number one for today's live streaming. Victoria, you are number 1. I am following. Okay, so what is the instantaneous value of AC current? What is the instantaneous value of AC current? The instantaneous value of AC current. Instantaneous value is the same thing as having I peak value, okay, sine WT plus phi. Okay, this is correct. Instantaneous is also called root mean square. Root mean square. So what is the peak value of AC current? Peak value of AC current is the same as maximum value of the current. Peak value of AC current is equal to maximum. What is the instantaneous value of the current? What is the instantaneous value of AC current? Okay, so instantaneous value of AC current. Instantaneous value is the same thing as having I peak value sine WT plus phi. This is correct. Instantaneous is also called root mean square. Root mean square. So what is the value of AC current? What is the peak to peak value of AC current? Value of AC current is the same as maximum value of peak to peak value of AC current is the same as twice the peak value. Is equal to maximum value of current twice the peak value. Okay, so are you there? Are you there? If you are there, say I'm here. Are you there? If you are here, say I'm here. What is the root mean square value of AC current? Root mean square value of AC current is the same thing as 1 peak value all over root 2. Peak value. What is the peak value of AC current? Peak to peak value of AC current is the same as twice value. Okay. Instantaneous voltage is equal to V sine WT plus phi. This is instantaneous voltage. The root mean square value of AC voltage, VRMS, is equal to VM all over this. What is the root mean square value of AC current? Root mean square value of AC. What is the phase of AC current? What is the phase of AC current? The phase of AC current is equal to WT plus phi. Okay. Instantaneous voltage is equal to V sine WT plus phi. This is instantaneous voltage. root mean square volt value of AC voltage VRMS is equal to VN. What is the phase difference between two AC quantities? What is the phase difference between two AC quantities? What is the phase of AC current? What is the phase? The answer is the difference in their phases. The difference in their phases. The difference in their phases. Are you there? Are you still following? Keep on liking. Keep on liking. Which question are you talking about? Which one? Okay. What is the phase difference between two AC quantities? What is the phase difference between two AC quantities? The phase difference between two AC quantities. Okay. The answer is the difference in their phases. What is the power in AC circuit? Power in AC circuit. Power in AC circuit. Okay. Power in AC circuit. P is equal to VI cos phi. So this is power in AC circuit, where V is voltage, I is current, cos phi. This is power factor. Okay. So that is the real power. This one is the real power. Real power. Real power. Okay, so power factor. Power factor. PF is equal to cos phi. So this is power factor. Okay, so what is the reactive power? Reactive power. This Q is reactive power. Reactive power is equal to VI sin phi. What is the SI unit of apparent power? SI unit of SI unit of apparent power. Apparent power. SI unit of apparent power is apparent power volt ampere. The answer is volt ampere. Keep on liking. 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 What is the SI unit of reactive power? SI unit of reactive power. VAR. Are you following? Are you following? Are you following? Let me know in the comment section. Are you following? Are you following? Are you following? Let me know in the comment section. All right, so what is impedance? What is impedance? All right, so what is impedance? Impedance is the total what is impedance? Opposition. Opposition. Impedance is the total to AC current. Opposition. What is the SI unit of impedance? AC current. SI unit is in ohms. What is the SI unit of impedance? SI unit is in ohms. What is reactance? Reactance is the opposition to AC current due to inductance or capacitance. What is reactance? Reactance is the opposition to AC current due to inductance or capacitance. Reactance is the opposition. What is inductive reactance? Inductive reactance is equal to WL. What is inductive? W is equal to 2 pi F. So XL is equal to 2 pi FL. What is capacitive reactance? Capacitive reactance is 1 over XC, 1 over WC, which is 1 over 2 pi FC. 1 over WC, which is 1 over 2 pi FC. Keep on liking the video if you are following. Keep on liking the video if you are following. All right, so what is the impedance of a resistor in AC circuit? The impedance of a resistor in AC circuit, Z, is equal to R. So, what is the impedance of a resistor in AC circuit? The impedance of a resistor in AC circuit, Z, is equal to R. What is the impedance of an inductor in an AC circuit? The impedance of an inductor in an AC circuit is JXL. What is the impedance of an inductor in an AC circuit? The impedance of an inductor in an AC circuit is JXL or JWL. Or JWL. What is the impedance of a capacitor in AC circuit? Z is equal to 1 all over JWC. What is the impedance of a capacitor in AC circuit? What is the impedance of a series RLC circuit? The impedance of a series RLC circuit is square root of R squared plus XL minus XC all squared. What is resonance in AC circuit? What is resonance in AC circuit? Resonance in AC circuits occurs. What is resonance in AC circuit? Resonance in AC circuit occurs when XL is equal to XC or XL minus XC is equal to 0. XL is equal to XC or Z is equal to R or power factor is equal to 1. What is resonant frequency? Now we have our resonance. XL is equal to XC. So we have called this resonant frequency, whereby this is 2 pi F naught L equal to 1 all over 2 pi F naught C. F naught is the resonant frequency. Resonant frequency. So we make F naught the subject of formula. That is all. Cross and multiply 4 pi squared F naught squared LC is equal to 1. So F naught squared is equal to 1 all over 4 pi squared LC. So take the square root of both sides. You have F naught is equal to 1 all over square root of 4 pi squared LC. So which makes F naught is equal to 1 all over 2 pi square root of LC. So this is resonant frequency. This is resonant frequency. Are you there? Are you following? Are you there? Are you following? What is the magnitude of impedance? Magnitude of impedance is R squared plus X squared, where X is equal to XL minus XC. Magnitude of impedance is R squared plus X. What is the phase angle of impedance? Phase angle of impedance is tan inverse of X all over R. What is the phase angle of impedance? Phase angle of impedance is tan inverse of X. To get current, remember V all over impedance. To get current, remember V all over impedance, where V is equal to IZ. So there is what you call admittance. So admittance is the reciprocal of impedance. There is what you call admittance. Admittance is the reciprocal of impedance. Okay. Okay. So the SI unit of admittance, admittance is Siemens. SI unit of admittance is Siemens. SI unit of admittance is Siemens. What is conductance? SI unit of admittance is Siemens. What is conductance? What is conductance? Conductance is the real part of admittance. What is conductance? Conductance is the real part of admittance. Conductance is the real part of admittance. G. Conductance is the real part of admittance. Conductance is the real part of admittance. What is susceptance? What is susceptance? Susceptance is the imaginary part of admittance. What is susceptance? Susceptance is the imaginary part of admittance. All right. At this point, we can say we are done with alternating current. At this point, we can say we are done alternating current. Okay, let's look at wave once again. Okay, let's look at wave once again. So what do you mean by mechanical wave? So what do you mean by mechanical wave? What do you mean by mechanical wave? Are you ready for us to go with wave, or you are not? If you are ready, say I am ready. Or we just leave it. What do you mean by mechanical wave? Are you ready for us to go with wave, or you are not? If you are ready, say I am ready. Or we just leave it. What do you mean by mechanical wave? Are you ready for us to go with wave, or you are not? If you are ready, say I am ready. Keep on sharing, like the video, like the video. Keep on sharing, like the video, like the video. We are going to hit on wave and finish it. Keep on sharing. Let's see how we can hit on wave. Keep on sharing, okay? All right, so if you are asked what is a mechanical wave, a mechanical wave is a disturbance that travels through a medium. If you are asked what's a mechanical wave, a mechanical wave is a disturbance that travels through a medium. So a mechanical wave travels through a medium. What is the amplitude of a wave? The amplitude of a wave. So a mechanical wave travels through a medium. What is the amplitude of a wave? The amplitude of a wave. The amplitude is the maximum displacement from the equilibrium position. Keep on sharing. Keep on sharing. Keep on sharing. Like. What is the wavelength of a wave? What is the wavelength of a wave? This is the distance between two consecutive points in the same phase. The distance between two consecutive points in the same phase. So amplitude, the symbol is A. Wavelength, the distance is lambda. Now, the unit of amplitude is meters. Meters, wavelength too. Wavelength, the distance is lambda. Okay. Unit of amplitude. What is the frequency of a wave? Frequency is the number of oscillations per second. Frequency is the number of oscillations per second. Frequency is the number of oscillations per second. Okay, so is the number of oscillations per second. And is the reciprocal of period, 1 over period. So, unit is hertz or second by 1. And is the reciprocal of period, 1 over period. Unit is hertz. Then period is the time taken for one complete oscillation. Okay? Period is the time taken for one complete oscillation. The period is the time taken for one complete oscillation. The relationship between frequency and period is F equal to 1 over K. Wave velocity or wave speed is the distance traveled by the wave per unit time. Wave velocity is the distance traveled by the wave per unit time. Wave velocity is the distance traveled by the wave. Then the wave equation we know is V is equal to F lambda. That is wave equation. V is equal to F lambda. What is a transverse wave? 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 A transverse wave is a wave in which the particles vibrate perpendicular to the direction of propagation. A wave in which the particles vibrate perpendicular to the direction of propagation. A wave in which the particles vibrate perpendicular to the direction of propagation. So here is crest. Crest. There is trough. Trough. Okay. So the distance between two consecutive crests is called wavelength. Okay. So from here to here, when you join it, you get wavelength. Here is 0, and here is 2 pi. So from here to here is the period. Is the period. Period is 2 pi.
No. Don't bring it up. Don't bring it up.
Okay, have you seen that we have crest, we have trough. This is transverse wave. This is transverse wave. Okay? This is transverse wave. Have you seen that we have crest, we have trough. This is transverse wave. This is transverse wave. Okay? Where A is amplitude, WT. Is the phase angle. So what is a longitudinal wave? What is a longitudinal wave? A longitudinal wave is a wave in which the particles vibrate parallel to the direction of propagation. A longitudinal wave is a wave in which the particles vibrate parallel to the direction of propagation. The longitudinal wave is a wave in which the particles vibrate parallel to the direction. What is a sound wave? A sound wave is a longitudinal wave that can be heard. A sound wave is a longitudinal wave that can be heard. A sound wave is a longitudinal wave that can be heard. The speed of sound in air at room temperature is approximately 3. Speed of sound in air at room temperature is approximately 343 meters per second. Speed of sound. This is speed of sound in air. Now, speed of sound in water. This is speed of sound in water is approximately 1,500 meters per second. And speed of sound in still is approximately 5,000 meters per second. In still is approximately 5,000 meters per second. In still. So what is the pitch of a sound? What is the pitch of a sound? Pitch. I hope you are following. What is the pitch of a sound? What is the pitch of a sound? Pitch. I hope you are following. What is the pitch of a sound? The pitch of a sound is the frequency of the sound wave. The frequency of the sound wave. The pitch of a sound is the frequency of a sound wave. The frequency of the sound wave. The pitch of the sound is the frequency of the sound wave. I hope you are following. Keep on liking. Keep on liking. Okay. Remember, the pitch of a sound is the frequency of the sound wave. Then, what is the loudness of a sound? Okay. The loudness. Remember, the pitch of a sound is the frequency of the sound wave. Of a sound. The loudness of the sound is the amplitude of the sound wave. The loudness of the sound is the amplitude of the sound wave. I hope you are following. I hope you are following. Okay, so what is the audible frequency range for human? Audible frequency range for human is 20 hertz to 20,000 hertz. Audible frequency range for human is 20 hertz to 20,000 hertz. 20 hertz to 20,000 hertz. Within this range, you can hear. Or beyond this range, you cannot hear. It's beyond us. So that is the audible frequency range for humans. What is infrared sound? Infrasound. What is infrasound? Infrasound Infrasound is the sound with frequency below 20 Hz. Sound with frequency below 20 Hz. Sound with frequency below 20 Hz. Infrasound is the sound below 20 Hz. Okay, what is ultrasound? Infrasound is the sound below 20 Hz. What is ultrasound? Okay, what is ultrasound? Sound above. What is ultrasound? Sound with frequency above 20,000 Hz. With frequency above 20,000 Hz. Are you following? Are you following? We have 4 minutes to go. Are you following? Are you there? We just have 4 minutes to go. We have 4 minutes to go. We have 4 minutes to go. Are you following? Are you there? We just have 4 minutes to go. We have 4 minutes to go. So what is Doppler effect? What is Doppler effect? Doppler effect is the change in frequency due to relative motion between source and observer. Doppler effect is the change. What is Doppler effect? Doppler effect is the change in frequency due to relative motion between source and observer. Doppler effect is the change. Okay, so that is Doppler effect. Now, what is resonance? We have 3 minutes to go. What is resonance? Okay, so that is Doppler effect. Now, what is resonance? We have 3 minutes to go. What is resonance? Resonance is the phenomenon when the frequency of an external force matches the natural frequency of a system. Is the phenomenon when the is the phenomenon all right, so we shall continue with physics tomorrow by 7 a.m. same time in our lives. Like and share this video so that others can watch it, share it, and like the video. Okay, I so much appreciate you for being there till the end, till this time. I so much appreciate you all. Have a wonderful day. Have a blessed day. Share this video so that others can watch it, share it, and like the video. Okay? I so much appreciate you for being there till the end. during this time. Thanks so much. I appreciate you all. Have a wonderful day. Have a blessed day. Your consistency is going to bring you success. A success that you're going to cherish. Thank you so much. Your consistency is going to bring you success. Success that you're going to cherish. Thank you so much. Consistency is going to bring you success. Success